So today we are going to discuss about set. Set is so what is basically set is? So set is collection of well-defined collection of same type of object. You can say that. Okay. So means a set will have only similar type of objects. Okay. So for example, you can say that like this. And set is represented by generally a capital letter and in the curly braces. So this is known as curly braces. Okay, so the elements of set will lie in this only. Okay, now let's say that I'm just writing down some states. So UP, Uttar Pradesh, MP, and you can say Uttarakhand, and AP, Andhra Pradesh. Okay, so these are the some states of India, right? So all are states of India, so that is fine. It is a set. But let's say a set B. B is going to be A, E, I, O, S, right? So it is not a collection of same type of objects or thing. There four terms are vowel and one is consonants. So it is not a set. So it is not a set. So set is generally represented by capital letter and it is a collection of similar type of object. Okay, so so this is how you can do this. Now one more thing. So if A is an element, right? So A is an element. So I have to write A belongs to the set A. I can write it like this. A is an element of. It can be written as element of. Or you can write it belongs to. So A belongs to capital A. Okay. Or you can say that P. P does not belongs to B. Not A, it is B. P does not belongs to B. This will be read as B does not belongs to set B. This is set B. Okay, and the elements are generally represented by a small letter. Okay, so capital letter for set and small letter for their elements. So P does not belongs to B. Okay, so this is what is set about. Okay, now one more thing about this. Set does not allow duplicate or you can it does not allow actually repeated elements, right? You cannot write it like this. A equals to A comma A. This is equivalent to just A. Okay, so duplicate things are not allowed. Duplicate set does not allow duplicate objects, so you should keep this in mind. Okay, so that is. Now the next thing is set have different form of representation. You can think about it, right? Why this different form is required. Okay, so it is possible we have some defined, means if I'm going to say B is a collection of vowels, okay, or consonants. So they are very limited, 21 consonant and 5 vowels. But there it is possible to have elements which have if we are starting to count them, they are going to be infinite, right? So for that purpose, and we can't write the infinite terms in a set. Okay, so this is a very difficult task. So for that purpose, we come up with some new method or new form, you can say. Okay, so there are two form of set. One is roster form and other is set builder form. So let's see what they are. So when you are going to write each element of set individually, okay, so that form is known as roster form. So there are two forms, roster form and the other is set builder form. Okay, so roster form and set builder form. So let's say I take a set A and A, E, I, O, U, right? So A is just a collection of vowels of English alphabet. So this is a one way of representing it, where we are going to put all the elements in that particular set. In set builder form, how I can write it? A is equals to X such that this is a symbol for such that X is a vowel of English alphabet. Okay, so X is a vowel of English alphabet. So there are 5 alphabets, so this is very easy to write it down, right? So this is how you can do this. Now let's see B. B is 1 upon 2, 2 upon 3, 3 upon 4, 4 upon 5, 5 upon 6, and so on. Right, means it is going in indefinitely. Okay, so so what you can see here, it is going to infinite, right? And still we are not able to write it all the elements. So for that purpose we just leave it by dash. Okay, so this is the basically drawback, if you can say it. It means this is not like you cannot write it down every element. You cannot write every element. Okay, so to remove this kind of situation, they come up with set builder form. In set builder form, what you can do, you can write it something like in words, so that it is very easy to understood, and you can get any element you want, right? So what you can do, so now I have to write it in set builder form. So B is going to be, B is equals to X such that X is equals to n upon n plus 1. Okay, X is equals to n upon n plus 1. And one more thing, how will you know that X is equals to n upon n plus 1? By looking this pattern. Okay, always they will give you this type of form, so that you can easily identify what it is. So X is equals to n upon n plus 1. And what about n? N is starting from 1 and going to infinitely. So you can just say it, n belongs to a natural number. Right. Okay. So this is how you can do this. So this is a roster form. Now C. Well, so this is a roster form, and you have converted it into set builder form. So it is possible they will give you some set, and it will be in a roster form, and they will ask you to convert into roster form, right? It means they will give you in set builder form, and they will ask you to convert it into roster form. So how can you do this? So C is this. So X such that X is equals to n upon n square minus 1, or let's say n upon n square minus 2, and n belongs to natural number, and n is less than or equals to 5, right? So n is a natural number and it is less than or equal to 5. I have to convert it into set builder form. So actually in in roster form. So in order to convert it into roster form, I have to write each and every possible value of x. Okay, so what is C? So just I can put so n belongs to a natural number, so I can start from 1. Okay, so if I substitute with the value of n as 1, so what I am going to get 1 upon 1 minus 2, and for when I substitute n equals to 2, this is going to be 2 upon 4 minus 2, 3 upon 9 minus 2, 4 upon 16 minus 2, 5 upon 25 minus 2. This is half. Okay, after simplification it is going to be 1 upon minus n is minus 1, 2 upon 2 is 4 minus 2 is minus 1, it is also going to be minus 1, right? And 3 upon 9 minus 2, 9 minus 2 is 7, so 3 upon 7, and 4 upon 40, and 5 upon 23. Can I write it like this? And or I can say you how many elements are there in C? 1, 2, 3, 4, 5, 5, right? But it's wrong. Why? Because minus 1 is repeated. Okay, so repetition is not allowed in set. So C will be written as minus 1, 3 upon 7, 4 upon 40, and 5 upon 23. Okay, so this will be your set C. Okay, so this can be written as this. So this is how you can convert it roster form into set builder form, and set builder form in roster form. So this is very simple. Okay, so this is not a very tough work, so you can do it. Okay, so now we are going further. next important thing is types of sets. So there are different types of set are possible. Okay, so we are going to deal with them. So set. So first you can write it. One thing is null set. Okay, so what do you mean by null set? Null means null. Okay, so null set means when the set have no elements, right? So it is generally represented by like this, curly braces just with no element, or this can be represented by this 5. Okay, so can you give me an example of a set which has no element? Well, think about it. Okay, so I can give you like this: a is equals to x such that x square plus x plus 1 equals to 0. Okay, so there is no element of x for which x square plus x plus 1 equals to 0. That is why it is a null set, right? Or you can write it like this: x is such that x square plus 4 is equals to 0. Okay, again there is no value of x for which x square plus 4 is going to be 0. So these two are the example of null set, right? Or you can write it like this. Let's just see. This x such that x is equals to 1/2, or like this. Okay, so x is such that x plus 4 equals to 0 and x is a natural number. So if x plus 4 is equals to 0, the value of x is going to be -4. But x is a natural number, so it is not possible. Okay, so that is why it is also going to be an example of null set, right? So this is an example of null set. Now second set is equivalent set. Okay, equivalent set is basically for two sets, right? Two sets will be said to be equivalent if A and B will be equivalent if number of element, this NA represents number of element in A, is equals to number of element in B. Okay, for example, A is equals to A, E, I, and B is equals to P, Q, R. So these two are equivalent because the number of elements is same in these two cases, right? And number of element of a set is also known as cardinality, right? So you should know what it is. Cardinality of a set, right? So cardinality means number of element in a set. Number of element in a set. Set, right? So this is known as cardinality of a set. And third one is equal set. Again, it is also for two set. A and B will be equal if number of element and elements are same in both set. Got it? So A and B will be equal if number of element as well as elements are same, right? So you can write it like this: A is equals to A, E, I, O, U, and B is equals to E, I, O, U, and A. So order doesn't matter, right? So order doesn't matter. So the elements and number of elements are going should be same. So what can you say about equal set and equivalent set? Okay, so one more thing: A and B are equal. So this will be written like this. So A and B are equal, then you can write it like this. Okay. Now every equal set is equivalent, right? Every equal set is equivalent, but reverse may not be true, right? Every equal set is equivalent, but converse need not to be true. Okay, so converse may not be same, but if equal set is always equivalent, but equivalent may or may not be equal set. So please make a note of this. So this is what about null set, equivalent set, equal set. So we are going to see some more example, means type of set. So next is finite set, right? So finite set and infinite set, you can classify them on this basis also, right? So what is finite set? As name suggests, finite set is something with limited number, countable number of elements. Okay, so that is what is known as finite set. So finite set, okay, having the set having finite number of elements. Set having finite number of element. Okay, finite number of element. So a set having finite number of elements. So for example, set of vowels, set of consonants, right? So they all are finite. So a is equals to 1, 2, 3, 4, 5, right? They all are finite sets. In the next is infinite set. Set having infinite element, having infinite number of element. If a set have infinite element, then it will be an infinite set. For example, a x such that x belongs to a natural number. So there are infinite natural number. So it will be infinite set, right? So, and what else? So finite set, infinite set, and so that's it. Okay, so this is what you can do about this.